In this video, we're going to define the 6 general quadric surfaces. So we're going to start with a general shape called an ellipsoid. So what does an ellipsoid standard form look like? We say x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Which, if we took this z squared over c squared out, that would be the equation of an ellipse in standard form. We both have positive coefficients. They're all plus signs equal to 1. So what does this look like? And does it have easily identifiable intercepts? So we can state the intercepts of something that is in this form. So again, we have all positives in here. All my terms are positive. There's no minus. So we know this is going to be an ellipsoid. We have x squared, y squared, and z squared. The intercepts, well, if I let x and y be 0, I'm going to get a positive and negative c value. If I let x and z be 0, I would get a positive and negative b value for my y. And if I let y and z be 0, I would get plus minus a in here for my x. So I have 6 intercepts, 2 on the x-axis, 2 on the y-axis, and 2 on the z-axis. If we think about trying to graph this, we want to think about traces, and we kind of did that in the last one. So what would happen, say, if we choose x to equal a number or a constant? So if I let x be a constant here, that turns this into a constant. I could subtract it over to that side. So what shape would that be if x became a constant? If x became a constant and I moved it over, I would have a ellipse. And that ellipse would be in the YZ plane. So I have an ellipse in the YZ plane. How about if I choose y equal to a number? So if I let y be a number, again, this whole term would become a constant because a, b, and c are constants. So that's a constant, subtract it over. Again, I have the form of an ellipse. And that would be an ellipse in the xz plane. And you should be able to see that if I let z equal a number, I would also get an ellipse in the xy plane. All right, so what does this graph look like? So graphing this, I make my 3-space graph here. So we're going to go out the same distance in my x-plane because we have intercepts at a positive a and a negative a. Right, so we've got plus a and minus a out there. I don't want to get too many numbers in there just yet, but we've got positive a and negative a. My b's are going to be on that y-axis. So I'll put out my b. We've got a positive b. I'm sorry, that was a negative b and a positive b. And then we have z's, same distance off the origin, up z and down z. So what we want to do is think about drawing each of these 3 ellipses that we have here. So the first ellipse we have, we can think about an ellipse in the xy plane, right there. We can think about an ellipse in the YZ plane. And then this one's the hardest, an ellipse in the XZ plane right there. So I'm going to draw those 3. We have this ellipse going through here. That's in the XZ plane. I have an ellipse going that way in the XY plane. And then an ellipse forward in the YZ plane. Oh gosh, that looks terrible. In the YZ plane, it kind of looks like this. So you can see we have all these ellipses and they're all concentric and it creates this shape, which we can see. I'll kind of color it in. This elliptical shape here. Does it do that? It's kind of on the front of it. And then this is tracing down the back, etc. So I'm going to pull in a picture from the book because it probably looks way nicer than what I've drawn. So here we have it. And you can see it a little bit nicer. We have our ellipsoid on the screen. So you can see all of our cross sections in each of the three planes. Those are all going to be ellipses. And it just happens in this situation that the ellipse in our XY plane looks circular. But remember, a circle is just a very specific ellipse, just like a square is a specific rectangle. Okay, so we've got our standard form here. All of these coefficients in the bottom are constants, the a, b, and c. And then we have a plus x squared, a plus y squared, and a plus z squared equal to 1. So they can have different coefficients in front, but they're all positive. That's how we know it's an ellipsoid. 3 squared variables, all of which are positive. And this just breaks down each of those 3 ellipses that we trace.